Okay, everyone. So here's our second example. Let's talk about it, and then you're going to try to solve it. So what we have is a 100-kilogram table and has a mass center at G right here. The coefficient of static friction between the legs of the table and the bed of the trucks is simply 0.2. And our question is this: what is the maximum acceleration possible without causing the table to move relative to the truck? And what are the normal reactions on legs A and B? So what I want you to do is go forward, try it on your own. So pause the video and then come back and see how you did. So how are you going to do this? Well, just follow that procedure I gave you a while ago. So 3, 2, 1, and we're back, and hopefully it went well, and maybe it didn't. If it didn't, well, that's okay. We're here. We'll get through this together and we'll try it out now. So first off, this table is going to have rectilinear motion. How do we know that? Well, the truck is moving in a straight line. It's not curving. It's not going up a hill, down a hill. It's most definitely not tumbling over end. And so with that, it's going to be rectilinear motion. So if we look at our table, we're going to know, well, there's the weight at the center. And we're going to have frictional force, which is trying to stop it from moving. It's pushing this way. It's pushing to the right because the table is going to try to fall off the back of the truck. So it'll be moving to the left. We have a normal force at points B and A. And then our table itself, we're just going to go ahead and draw the sense of the direction there. Also, be very, very careful that your frictional forces, they're connected to the correct normal force. Don't just write in here. If you forget that sub, you're going to get a completely wrong answer. So now we apply our equations of motion. So first off, so the forces in the x direction is going to be equal to our mass times our acceleration in the x direction. So that means we have several forces. We have our frictional force right here and our frictional force right here. And that's going to be equal to 100 times the center of gravity. Sorry, the acceleration is center of gravity. What's the sum of the forces in the y direction? Well, that's going to be equal to my normal force at A plus my normal force at B minus 981. And then finally, what are the sum of the moments around point G? Well, they are going to be equal to my normal force right here, all of these, acting on the body with that distance. Now, one thing you might be wondering is, well, where did my friction go? This is the friction. That's the 0.2 times the normal force. That is friction right there. So don't get confused by that, and be very, very careful about your signs. Okay? That's probably one of the biggest mistakes whenever we do some of the moments. So if we solve that, what we get is our normal force at A is 294 newtons. Normal force at B is 687 newtons. And the maximum acceleration you can reach before it falls off the back of the truck is 1.96 meters per second squared. That's not technically true. I guess you could go a little bit higher. Like you could probably get to 2. You have like a second or 2, so technically you can accelerate more than this. It's just going to start sliding when that happens. But, you get half a second before it falls off. Okay, well, that's enough of that. So thank you for listening. I hope this helps, and I'll see you all next time. Just remember, it's just the same equations we've been using, just applied slightly differently because we've got a rigid body now. So have a great day. Bye-bye.